Okay. How'd you solve that? I hear somebody talking.
Log base of 3 equals to 24. Sorry, log base of 3 by 27 plus 5.
How can you do it without logs?
27 is just the distance of the power of 3. Then you multiply that by 10 minutes.
Want us to write this in?
Yeah. Now what? Nope. Can't do that yet. Right. So you have to simplify this. Reduce 3 to the.
15.
Now what? Now that the bases are the same, they can go solve what's left. So take 15x over here and it becomes negative 13x. Take 1 over here and it becomes negative 1. What's my final answer? Positive 1 over positive 13. Okay? That's like from lesson 7.3. Okay? That's when we did exponential equations. You made the bases the same so you could cancel them out. Okay? Now the reason that I'm giving you this, okay, is because what if I gave you that? Now you use a log, okay? Because we can't make the bases the same. Okay, we have no idea. So what we would have to do is take the log of both sides, and we'd have to be using the calculator. Okay? Because these are not going to give us nice, clean numbers. So we're going to have to do some calculations involving logs. So that's the final type of equation we're going to look at, is what happens when we have an exponential equation using, when we have an exponential equation that we can't make the bases the same, we use logs. So when we encounter this situation, we take the common log. Remember, common log is base 10. So you're just going to log both sides. After you do that, you may have to do some simplifying, or you likely will, using the log laws. So like if we if we had two logs, the same base that we're adding, that's the same as a single log with the arguments getting multiplied. Then we have the division one, then we have the power one. So when you do that, we have to use algebra after that to isolate the variable. In other words, solve. Solve what's left. Because that's the whole purpose. However, we may encounter situations when we take the logs of both sides where more than one of the terms will have a variable in it. Okay? So if that's the case, we're going to have to GCF factor, and you'll see that when we do some examples. So remember, when you see these things, take a look first to see if you can make the bases the same. Okay? Because if you can make the bases the same, it becomes a much easier equation. But in this one, no, I can't make 40 into base 5. So the first thing I'm going to do is I'm going to log both sides. Like so. I can do a log law to simplify the left side. What can I do? A power law. I can bring this in front here. So I get, remember, log base 10, 5 to the x is the same as, sorry, log base 10, 5 to the x is the same as x times log base 10 times 5. And there's a reason that I did that, is because now I can isolate the variable. Remember, this is x times log 5. How do I get x by itself? Divide by log 5. Divide by log 5. Those cancel. Divide by log 5. So my answer x is going to be the log of 40 divided by the log of 5. Now we have to use our calculator. Go to 3 decimal places. And you should be familiar with how to use your calculator for logs. So log, like my calculator, when I press log, it automatically opens up parentheses. So I'm going to do log and then 40, close parentheses, divide log 5, close those parentheses, and I should get 2.292. Okay, this next one. Can't make the bases the same. Can't make 3 and 4 the same. So I'm going to log both sides. Now do the power log law to bring the exponents down in front of the logs. So like that and like that. So this is going to turn into x log 4 equals, and this, the 2x minus 1 has to stay together. So how do I do this? I got to use parentheses. What's that? Oh, sorry. Make no mistakes, guys. That's top one. Okay, what can I do to the right-hand side? Well, I can multiply log 3 by everything inside. So 2x times log 3 is 2x log 3. Minus 1 times log 3 is just minus 1 log 3 or minus log 3. Here's a situation where we have variables in 2 terms. Here and here. I've got to get them on the same side. So how do I get them on the same side? I got to take this over to this side by subtracting. So when I do that, I'm going to get x log 4 minus 2x log 3 equals negative log 3. How do I isolate the x? How do I get the x out of both of these terms? Factor it out. So if I take out an x from both of these terms, I'm left with log 4 minus 2 log 3 equals negative log 3. Now I can get rid of this from the left-hand side by dividing it away. So I divide by log 4 minus 2 log 3 to cancel it out there, but then I got to do the same thing here. Divide by log 4 minus 2 log 3. Now this is a little tricky to do on your calculator. So you got to make sure you know how to do it. Okay? Remember, when we have a fraction bar, we have to do everything up top first, so have parentheses around it, everything on the bottom, and divide at the end. So what I would do is I would open up a set of parentheses and then put negative log 3. Notice when I hit the log, it opened up another set of parentheses, so that means I got to close them twice. Okay. So it's going to look like this on most calculators. It's going to look like that. Okay, because remember, on most calculators, when you hit log, it's going to ask you to open up a set of parentheses. So then I'm going to divide that. Now I got to open up a set here. I don't need these ones here. And then I got to go log 4. It opens up a set, so I got to close the 4 off. Minus 2 log, and it opens up a set 3, close that set off, and then close the big set off. And you should, if you do it correctly, 1.355. If you're not sure how to do it on your calculator, make sure to come see me. And works great on the graphing calculator, and those types of calculators that I told you guys to get since grade 9. I wonder if anybody actually has. Yeah. Good job. Good job. Looking out the window. Ah, here's one. Academy wasn't even in here in grade 9. This one I told you guys to get, like grade 9, 10, 11. But nope, you didn't listen. You just want to look out the window and smash cars if you have some sort of violence fetish. Okay. But that's okay.
Maybe everyone should be blank so not with them.
So 1.355. Okay, come on, pay attention, please. Next one. Already read it. All right, I want you guys to try this one. See how far you can go. I gotta go up. I gotta go up. Thank you. It always says it up top, but then it tells me to go up. Give it a shot. Well, you should. First step should be pretty straightforward. Log both sides.
three also on this side.
Okay. Now what?
The exponent side in front of.
You have to bring those exponents in front of the logs on each side. In parentheses, yes. Good.
Yeah, you see this?
What's next?
Distribute.
Yeah, distribute or multiply through. So x log 7 minus 5 log 7 equals x log 3 plus 2 log 3. I've got multiple x's. So that means that I have to bring this one over here by subtracting x log 3. And at the same time, I'm going to bring this one over here by doing what? Adding 5 log 7. Might as well. I mean, you can do them in 2 steps. That's fine. I'm just going to do it in 1 step. So when I do that, I'm going to get, there's still an x log 7 here. The minus x log 3 has joined it. On this side, there was already a 2 log 3. And then the minus 5 log 7 has joined it by becoming plus. What's my next step? Factor out the x. And then divide both sides by x log 7, or sorry, log 7 minus log 3. Now remember your parentheses. Most calculators, whenever you press log, it's going to open up a set. So you always have to close those off after you enter the numbers. But we also have to have big ones around the numerator and the denominator. So see if you can do it. I won't give the answer until somebody thinks they have it. Maybe. What did you get, Doyoung? 14.076. Yep, that's right. Okay. Next one, can't make the bases the same. Log both sides. This looks a little, because we've got a 2 times 3 to the x. Well, we can deal with that. Exactly. You have to expand this into 2 separate logs. So remember our multiplication log law. If you take the log of 2 arguments being multiplied, that's the same as taking the log of the first argument plus the log of the second. So that's what we have to do when you see that. If it was a division one, like if it was 3 to the x over 2, then I do subtraction. Equals log 5 to the x minus 1. What's that? Just this one? Are there any other exponents to bring down? Yeah, here. So log 2 plus x log 3 equals, and whenever there's more than one term in the exponent, make sure you put parentheses around it, x minus 1 log 5. My next step, I gotta multiply this out. I can't bring everything together yet until this is multiplied out. So log 2 plus x log 3 equals x log 5 minus 1 log 5, or just minus log 5. What? No?
Subtract the x log 5.
What?
Like bring the x log 5 in the right.
Oh, I thought you were telling me I did something wrong. You're telling me now, do this. Bring this over here by minus x log 5. Bring this over here by minus log 2. That's right. Why am I doing that? Because I'm getting the x's all together on one side. Yes, the people. Sometimes called terms, but sure, the people. If you want to refer to logs, it's a living thing. Hey, if it helps you remember, do it. Absolutely. So, I already have a log 2 here. Oh, sorry, this is.
X log 3.
Oh, sorry, no. I got the x's there. So there's already an x log 3 here, minus x log 5.
Equals to minus log.
Equals minus log 5 minus log 2. And you should be able to see the last step. Sorry, the second last step. Factor it out and then divide it by both sides. So therefore, I'm not going to show this step this time. It would be minus log 5 minus log 2 divided by log 3 minus log 5. Now remember your parentheses. Yes. It works out to 4.508.
It's gonna do.
4.508. Okay. Next one. Don't get overly excited. Think about what question am I asking every time I start one of these questions. Can I make the basis the same?
Yeah.
This one I can. I don't have to log both sides. If you log both sides, it requires more work, but you still get the right answer. It's just you're going to have to do a lot more work. So notice whenever I have exponential equations, okay, there's two types of exponential equations, just like there's two types of log equations. So I check to see if I can make the basis the same. If I can't, I log both sides and go from there. How can I change the right-hand side?
And really, you want to open the place. She go ahead.
The right 4 is our base 2.
2, 4.
2 squared to the x. I have to use an exponent law to simplify the right-hand side. It becomes 2 to the 2x. Take them out, solve what's left. Take the 2x over here, you get x. Take the -1 over to the right, you get 1, and you're done. Would you like me to show that out? So I'm going to take this over here, and I get x minus 1 equals 0. Then I'm going to add 1 to both sides. I get x equals 1. That's how I do it. F, you could log both sides, but can you make them the same base? Yeah, I can write 1 as any power as long as it's raised to the what? Anything raised to the what is always 1. 0. Anything raised to the 0 is always 1. So this is the same as 4 to the x plus 3 equals 4 to the 0. Well, that's very straightforward to solve. X equals -3. Okay. So remember, we have 2 types of exponential equations. The very first ones we learned. Made the base the same, and we solve from that. So an example of this would be something like 5 to the x equals 125 to the 3x plus 7. That would be an example. The other one, we can't make the basis the same. Log both sides. Solve from that. So I'll just write a very similar one. Except this time I'll write a base right-hand side that you can't make the basis the same. Must have been standing with a slant when I wrote that first one. Log equations, which we did Monday. Again, there's 2 types. One type is when all the terms are logs. Actually, I'll put that. All terms are logs. Make a single log on each side by using your log laws. cancel out logs. And then so an example of that would be, let's say log 5 plus log x equals log 14. So this one you can combine to log 5x, cancel out the logs, and you're left with 5x equals 14, x equals 14 over 5. Okay, so everything, all the terms are logs. The other one is one term is a constant, a number. So for this, and the constant by itself on one side, same thing. On one side, change to exponent form. Solve from there. So an example here would be log 5 plus log x equals 4. So this one you'd have to combine it to log 5x. Okay, just I'll show you as we go through this one. This one has to become log 5x. That's one of the log laws. Well, you can't cancel out logs. So remember, this is base 10, so now you got to change it to exponent form. So 10 to the 4th would equal 5x, and then solve from there. And when, one other thing, when you have log equations, you do have to worry about restrictions. Okay. You don't have to worry about restrictions in exponential equations. So really this test coming up is just, I mean, it's got two big things right now: how to graph exponential and log functions, and how to solve these different types of equations. There's going to be a third chunk, which is the last lesson in the unit, which is how do we deal with problem solving involving these. Okay, but we'll start that next week.
Test we do like